Hello, Honors Algebra 2. Hope you all are doing well today. It is Thursday, March 26th. It's kind of hard to remember the days after you're home all the time, as I'm sure you're figuring that out as well. I wanted to just quickly show you what the Google Classroom looks like for today. I've really been trying to revamp and make things as clear and concise as possible. So you see for March 26th, the agenda is posted first, and then we have on the side different sessions for today. So there's a Zoom session at 9:30. There is a recorded video lesson, which is this that you're watching, and then it has your homework assignment, which is the section 8.1 to 8.3 review worksheet, and that's what I'm going to kind of start with you. There's also solutions posted so that you are checking your work. We will have a quiz next Wednesday. There will be another video Zoom lesson on Wednesday at 8 o'clock. I have to now change it to the regular school setting starting next week. So our class runs from 7:45 to approximately 8:15. So the video will go from 8 to 8:30. The Zoom session will go from 8 to 8:30. And again, I have to correspond with our school schedule. So if you're participating in Zoom, I'll see you at 8:30. Starting during the school schedule next Wednesday, April 1st. Okay, so let's look at the review worksheet. If you want to have that printed out or if you just want to take notes on a separate piece of paper right now, kind of up to you how you want to do that, or if you want to have two devices working, if you have two separate devices where you're watching the video and then writing on your iPad for the review worksheet. Feel free to pause it right now so you can get out a piece of paper or find the review worksheet on your iPad in the Google Classroom. So this is the review worksheet for 8.1 to 8.3, which is a good preparation for your quiz for 8.1 to 8.3. The four questions want you to decide if it's a direct variation, which is in the form y equals k times x, an inverse variation, which is the form y equals K or A. I think we used A. I think K is in my other class. A over X. If it's neither, it's not one of those and it's something totally else. You need to show some type of work. So looking at the first one, if I take the 2 to the other side by multiplying it, I got y equals 2x, which is a direct variation. That's the minimal amount of work that I need to see. For questions 5, 6, and 7, it says they vary inversely. Again, that's y equals a divided by x. And it wants you to use the given values to write an equation. Make sure you do that part. And then there's a second part. So if I want to write the equation, we have 2 equals a over x. So how about a is 3? Or x is 3, that means a equals 6, so the equation would be y equals 6 over x. So that would be the first part. Then it says find y when x is 2. Well, 6 divided by 2 gives us a value of 3 for y. So 2 steps, make sure you do both. 8 and 9 want you to decide what's going on with varying jointly. So it says the variable z varies jointly with x and y. So that means our equation is y equals a, let's start over, z equals a times x times y. So again, write an equation, make sure you do that part first. So z is 75. We're finding the variation constant a when we're given a 3 and a negative 15. A negative 5. My brain is not functioning, apparently, right now. So then we have 75 is equal to negative 15a, and a is equal to negative 5. So our equation, negative 5 x, y. So that's the equation part of the problem. And then the second part says find z. When x is 2 and y is 6. So that gives us negative 60. So again, make sure you're doing both parts of the problem. For the next three problems, it wants us to determine whether the chart shows a direct variation, again, y equals a times x, an inverse variation, y equals a divided by x, or neither. And an easy way to determine if it's an inverse variation or a direct variation is just to plug the ordered pairs into one of those equations and see if it matches it. So if you look at number 11, if I plug a y in of 4 and an x in of 2, and then I divide, I get a equals 2. If I continue to do that, I need to make sure that it is constant. The a value that I get is constant. So looking at the next pair, we have a 0.5 for y and a 4 for a. And when you divide, you get 0.125. Those numbers aren't the same, so then it's not a direct variation. Alright, well, now I'm going to see if it's the other way around. So I'm going to use, again, y equals a divided by x, and here a is 2. I'm going to try it again. Y is 0.5 equals a divided by 4. And I get a equals 2. And if I do it again, I have 12 equals a divided by 6. Alright, Miss Kane is messing up here. A is equal to 8. And then if I look at the second one, I get a equals 2. And then if I did it again, you can see that those are definitely different. And my next one would be a 72. So then it's not an inverse variation either. So that means this one is neither. But that would be the process that you would want to work through, determining if it's a direct variation, an inverse variation, or neither one of those options. Our next group of problems wants you to determine the vertical asymptotes and the horizontal asymptotes without graphing. Again, make sure you show some type of work, because it says find them algebraically. So if you have an answer that magically appears, then you didn't find it algebraically. So the vertical asymptote, minimal work here, denominator equals 0. I need to see that little teeny tiny piece of work. Horizontal asymptote is when you are looking at the powers. In this case, they're the same. So a 1 over 1 is just a 1. Make sure you set the denominator equal to 0 for the vertical asymptote. Some of them might need to be factored, and that's how you would solve them. And then the last group of problems wants you to find the x and the y-intercepts. The asymptotes, whether it's x equals or y equals for a vertical and horizontal, graph it by making a t-chart. And from that t-chart, you would use the x values that correspond with the vertical asymptotes. So make sure they're to the left, in the middle if there are 2 vertical asymptotes, and then to the right. And then finally, make sure you're listing the domain and the range. Number 17 is the problem one here that's different from the others. As you can see, number 17 is in the basic form. And this is the first form that we graphed, where it's a x minus h plus k. So when you are finding your asymptotes, your vertical asymptote is the opposite of h. Your horizontal asymptote is k. So just a little reminder, that one is slightly different. To get the x-intercept, you would set the equation equal to 0. For an x-intercept, you let the y equal 0. And to get the y-intercept, you let the x equal 0. You have a little bit of fraction work there, so make sure you're solving to find x for the x-intercept, to find y for the y-intercept. All of these solutions are posted under Google Classroom, so make sure you're checking your work. I also posted the graph there, so you can see what the graph looks like, so that you kind of get an idea if you're completing them correctly. Again, if you have questions, circle the question, write a question down or write it at the top of the page, but there will be a Zoom session on Wednesday, April 1st at 8 o'clock for us to go over any of these review questions or any of the questions from the review worksheet that you may have. Have a great day. If you need any help, feel free to email me.